Very good morning. Today we have the problem in the lambda iteration method. Already we have seen enough about the algorithm and the steps in the algorithm. So just like that, you need to remember. It's a very simple steps we have seen now. So you need to remember those steps for solving the problem. So the questions goes like here. The question you can take: determine the economic generation schedule of 3 generating units in a power system to the system load of 925 megawatt. To the system load of 925 megawatt. The operating limit and cost function. The operating limit and cost function is given below. Operating limit and fuel cost function is given below. So first, F1 of PG1. F1 of PG1 is equal to 0.0045 PG1 square plus 5.2 PG1 plus 580 dollars per hour. Next, the limit, the minimum and maximum operating limits for first generating unit is 250 megawatt less than or equal to PG1 less than or equal to 450 megawatt. That means whatever the power generated from the first generating unit should be within this limit, that is 250 megawatt to 450 megawatt. It should be within this limits. Next, fuel cost function of your generating station 2. F2 of PG2 is equal to 0.0056 PG2 square plus 4.5 PG2 plus 640 dollar per hour. Here the minimum and maximum operating limit is 200 megawatt less than or equal to PG2 less than or equal to 350 megawatt. Next, the fuel cost function of unit number 3, that is F3 of PG3, that is nothing but 0.0079 PG3 square plus 5.8 PG3 plus 820 dollar per hour. Minimum and maximum operating limit is 125 megawatt less than or equal to PG3 less than or equal to 215 megawatt. So this is the data is being given. So here if you see the what is the function given, fuel cost function is given. Sometimes here heat rate function also will be given. So if the heat rate function is given, the fuel rate of the particular generating unit also will be given in the problem. So while starting the problem, first we have to notice this thing, okay, whether it is fuel cost function or heat rate characteristics. Next, the general formulation already we have seen. Okay, Fi of PGI is equal to AI PGI square plus BI PGI plus CI. So these are the fuel cost coefficient. That is, this is A1. So for first generating unit, this is A1, this is B1, that is 5.2 is B1, this is C1. Next, for second generating unit, there is A2, B2, and C2. A3. So here third generating unit, here this term is A3, B3, and C3. So first, after writing the data of the problem, okay, in your notebook, so just write this A1, B1, C1. It is easy for you to substitute. It is easy for you to substitute. So that's why first of all, what you have to do is after writing down in the notebook, you have to write, you have to mention which is the fuel cost coefficient of unit number 1, 2, 3 like that. First you mention. Then it is easy for you to substitute. Okay. So what is the next step? What is the first step? First step in the algorithm: assign the initial values of lambda. So we have to assign the initial values of lambda. So what is lambda? Lambda is equal to PD, that is power demand, plus summation I is equal to 1 to n BI divided by 2AI, the whole divided by summation I is equal to 1 to n 1 divided by 2AI. So this is the formula for finding out the lambda. So what we need to do, we need to substitute. What is the power demand is given in the problem? That is 925 megawatt. First, this term, that is fuel cost function, the given terms you have to write with the minimum and maximum operating limits. Then PD, that is power demand, whatever the demand given in the problem, that you need to write. Next, substitution. Okay, so neatly solve, step by step solve. So step by step, if you solve means you'll get full marks. Okay, so and also the mistakes will not be happen. Okay, if you solve step by step, mistake, even if mistake happen also, you can easily find out. So that's why, that's what we said. And also steps also carries the marks. Don't simply write this formula, and just write a like a lambda value, then PG like that. If you write now, only some 2 or 3 marks only will be given, even though answer is correct. Okay, so first substitute. So here, what is the BI divided by 2AI means? So B1 plus 2A1 plus B2 plus 2A2 plus B3 plus 2A3. Okay, so here also 1 divided by 2A1 plus 1 divided by 2A2 plus 1 divided by 2A3. Like that, first you mention, then you substitute. Here PD is 925 plus megawatt plus here. What is the coefficient of here? First generating unit is B1. B1 is 5.2. So 5.2 divided by 2 into this term A1. A1 is 0.0045. 0.0045 plus, so here 4.5 divided by 2 into 0.0056 plus like that you need to substitute this term, third term B3 divided by 2 into this term 0.0079. So that also you need to substitute. So after this, 1 divided by 2A 1 plus 1 divided by 2A2 plus 1 divided by 2A3. So all these terms we need to substitute. Simply we need to substitute. So after substituting and simplification, simplification with your scientific calculator. I think in scientific calculator easily you can do this thing. Okay, rather than a normal calculator. So in scientific calculator, after calculation, you'll be getting lambda is equal to 8.62. Actually, I rounded off here, so don't round off. Okay. After decimal, you take 4 digits, whatever the value is coming, you take 4 digits. So I think, I hope you also get the same answer, that is lambda is equal to 8.62 something, but approximately you'll get this value, lambda is equal to 8.62. Okay, so next, what is the step number 2? Step number 2 is compute PGI. So how to compute PGI? PGI is equal to lambda minus BI divided by 2AI. As I already said, if you forgot how to frame this lambda, how to frame this PGI, just no need to worry about that. Just derive. Okay. So if you want to know more about this, you can refer our previous videos. Yeah. Here PGI. So what is the formula for PGI? Lambda minus BI divided by 2AI. So what is PG1? PG1 is equal to here. So this lambda 8.62 minus B1 5.2 divided by 2 into A1. So that value 2 into 0.0045. So that value you need to substitute, and after further simplification, you'll get PG1 is equal to 380 megawatt. 380 megawatt, something like that. I think you will get 379.9 something you may get. So I just rounded off, but don't round off. You don't round off whatever the value is coming. So after decimal 4 digits that you take. So this I am getting PG1 as 380 megawatt. Next PG2. PG2. So what is the value here? 8.62. 8.62 minus, so B2 divided by 2 into A2. So don't simply substitute. First you write this general formula, or otherwise directly you can write lambda minus B2 divided by 2A2. like that. Then after that you substitute. So PG2 you are getting like 367.85 megawatt. Again, so similarly for generating unit 3. Generating unit 3, if you substitute like 8.62 minus 5.8 divided by 2 into 0.0079. So after substituting, you are getting PG3 as 178.48 megawatt. Okay, so PG1, P1 all are same only. Okay, sometimes PG1, sometimes the problem itself will be given, the data itself will be given as instead of PG1, here it is given as P1. Sometimes only F1, like that also given in the problem, only F2, F3. So that is the function of the fuel cost function of unit number 1 is, it is a function of generating unit also, because it combines all your coefficient, fuel cost coefficients. Okay, so all are same only, F1, F2 or F3, send F of PG1, F of P1, like everything is same only, so don't get confused. Yeah, so here we calculated PG1, PG2 and PG3. Next, what we have to do, so after this you clearly write this terms, that is PG1, PG2, PG3, clearly write, comma, that limits. So whatever the limits given in the problem, simply write. Okay, then only to avoid the confusion. Okay, after this PG1, comma, 250 megawatt less than PG1, 450 megawatt. So PG2, that value, comma, 200 megawatt less than PG2, less than or equal to 350 megawatt. Next, PG3, 125 megawatt less than PG3, less than 250 megawatt. Like that you write. Next, you see, like, first it is satisfying the minimum and maximum operating limits or not. But if you see, like, this unit satisfies, so this PG2 value violates its upper operating limits. What is the value? PG2 operating limits is given in the problem. What is the, yeah, 200 megawatt less than or equal to 350 megawatt. It should be, whatever the generation should be, 200 to 350 megawatt. But if you see in the first generating unit satisfies, it is operate within the limit. I think third also, I think it is within the limit. And only second generating unit, it violates its upper operating limits. Then what we have to do? We have to fix that value. We have to fix that value to its upper operating limits. So whatever the value, it is not satisfying. What we need to do is we have to fix that value to its upper operating limits or lower operating limits. If it is violates its maximum operating limits, you have to fix to its maximum operating limits. If it is violates to its minimum operating limits, you have to fix that value to its minimum operating limits. Here, upper operating limits or lower operating limits is same only. Like upper operating limits is nothing but maximum operating limits. Lower operating, it's nothing but minimum operating limits. All are same only. You can use either maximum or minimum or upper or lower. So not at all a problem in the thing. Okay. So what we are doing is we are fixing this value because it violates its upper operating limits. So we are fixing this PG2 as 350 megawatt. So now we are fixing that PG2 as 350 megawatt. We are setting this PG2 as 350 megawatt. So we set this PG2 as 350 megawatt. So what is the next step? Next step, we have to check whether this limits of optimality limits, it is falling under the optimality, because we fixed some certain value, but we don't know whether the fixed value is correct or not. So what is the next step? Next step is to satisfy this optimality condition. Okay, so whether we are checking, because it violates its maximum operating limits now. So PGA is equal to PGA maximum. So this three things, this three optimality condition, we have derived. That is dFi divided by dPi is equal to lambda for PI minimum, PGA minimum less than or equal to PGA less than or equal to PGA maximum. Next, DFI divided by DPI is less than or equal to lambda for PI is equal to PI maximum if DFI divided by DPI greater than or equal to lambda for PI is equal to PI maximum. So this three operating condition we have derived. Okay, so first you write this three operating condition. So it is whether it is falling in which condition, because we have fixed this value, that is PG2 at PG2 to its upper operating limits, to its maximum operating limits. So what is the condition? So we fix the PGI as PGI maximum. So this condition, second condition, we need to satisfy. So second condition, what is the second condition? DFI divided by DPI is less than or equal to lambda. So here, what we are doing is DF2 divided by DP2 by taking PG2 as 350 megawatt. Okay, by taking PG2 as 350 megawatt, we are finding out this value, that is DF2 divided by DP2 value. So what is so already we differentiated. We didn't differentiate it. So what we need to do is we differentiate the fuel cost function 2 with fuel cost function 2 given in the problem. Already it is given in the problem. Yeah, this already given in the problem. What we need to do is we have to differentiate this fuel cost function 2 with respect to PG2. Okay, so here after differentiating, what is the answer we are getting? After differentiating, what is the answer we are getting? Yeah, after differentiating, we are getting 0.0112 PG2 plus 4.2. Okay, 4.2 is equal to lambda. Is we need to find out. Okay, we are finding out this this lambda value. Okay, so here while substituting PG2 as 350 megawatt, while substituting PG2 as 350 megawatt, so here you substitute 350 megawatt and find out the lambda. So here, if you find out, it is 8.42. We are getting 8.42 something. You will be getting exact value. Okay, so here, what is the condition here? So here, this condition you have to write here. Okay, the second condition you have to write here, that is DF2 divided by DP2 is less than or equal to lambda. Okay, less than or equal to lambda. So already we found out the lambda. What is the we found out the lambda value? What is the value of lambda? Already we found out. Yeah, here 8.62. 8.62 we already found out. Here, while substituting PG2 as 350 megawatt, we found out already DF2 divided by DP2. Okay, so this DF2 divided by DP2 should less than or equal to lambda. That is lambda already we found out, that is 8.62. So this value, what is this value? That is DF2 divided by DP2. We already found out, that is 8.42. So 8.42 should be less than or equal to 8.68. But here it is less than, not equal to. Here it is less than. It can also come like 8.62. Sometimes in this value, you can also get this value as 8.62 also. So in that case, it is less than or equal to. So here it is only less than. Okay, if either less than or less than or equal. So if this condition satisfied, okay. So whatever the considered value is correct. So if this condition is satisfied, okay, it is less than 8.6, that is lambda. Okay, 8.42, whatever that is DF2 divided by DP2 is less than this lambda, that is the lambda value. So this condition satisfied. Now only we are concluding. So we are setting this PG2 as 350 megawatts. Sometimes it is not setting, means you should not take that value. So sometimes it is violating. Say for example, you are getting this DF2 divided by DP2 as some 8.997, something like that. That value you are getting, it is not greater than, not less than or equal to lambda. In that condition, PG2 will not be 350 megawatt. See, whatever the considered value is wrong. Okay, whatever the considered value is wrong. So you need to proceed further. Okay, if that condition is not satisfied. Next, what is the next step? After finding out the optimality condition, what is the next step? So next step is we have to find out the PD new. So PD new is equal to PD old minus sum of fixed generation not satisfying the operating limits. Okay, go through my previous class. If you forget that algorithm, go through my previous class. So what is PD new? PD new is equal to PD old minus sum of fixed generation not satisfies the optimality limits. So what is PD old? PD old means whatever given in the problem. I think already we have taken that value as PD old as 925 megawatt. So sum of fixed generation not satisfies the optimality limit. So first generating unit and third generating unit already satisfied. Only second generating unit alone not satisfied. Okay, say for example in the problem only one unit only not satisfy the limits, minimum and operating limits. We set the value and that condition also satisfy. So we fix that value as 350 megawatt. Sometimes in some other problem, sometimes two generating units not satisfy the operating limits. In that scenario, what we need to do is we need to sum up all that two generating units. After verifying the optimality condition, after verifying all this condition, we have coming into the conclusion. No, so P1 is equal to some other value, PGT is equal to some other value, like that. After the conclusion, we need to sum up that that value not satisfying the optimality condition, that you need to add over here. Here only one unit only not satisfied. So directly I have taken 350 megawatt here. So you need to write that formula correctly. Okay, here minus sum of fixed generation not satisfy the optimality limits. So after that, so you need to find out PD new. So what is PD new? So 925 megawatt minus 350 megawatt. It is 575 megawatt. Again, so now how to find out after that, after finding out PD new. So you need to go to, so next step is to find out lambda new value. So what is the formula for lambda new? Same formula only, but here only it will change. Instead of PD, here you need to take PD new. Why? Because here we calculated a new value, that is for new demand value. Okay, new demand value we have taken. So here you have to add new demand value. Sometimes if you take the old PD like that, the answer will be coming wrong and it will not satisfy the demand, and the minimum and maximum operating limits also not satisfied. And again, what you guys will do is, again you need to continue the further steps. Again, if you do 1 or 2 iteration, 3 iteration also, it will not come answer will not come. Okay, so no, to avoid the confusion, so here you need to very careful. Okay, so lambda new is equal to PD new plus summation I is equal to 1 to n bi divided by 2a, the whole divided by summation I is equal to 1 to n 1 divided by 2a I. So here you need to substitute the values. But here one thing you need to understood, like already we have taken this PG2 value here, PG2 value that is 350 megawatt, and we have calculated PD new value. So by neglecting PG2 value, whichever not that PG2 satisfied, okay, we fixed that value. Okay, so apart from that, other thing you need to take. Okay, don't take that PG that is B2 divided by 2A2, or like in the denominator 1 divided by 2A2 value, don't take. Okay, only you need to take whichever the units satisfied, that you need to neglect over here. Okay, so if you take like, so only 2, so yeah, here after writing this formula, again you write like PD new plus B1 divided by 2A1 plus, so second generating unit you just neglect. Why? Because already that is satisfied. Already we feel condition also satisfied, optimality condition also satisfied, and we fixed that value. So here only B1 divided by 2A1 plus B3 divided by 2A3, the whole divided by 1 divided by 2A1 plus 1 divided by 2A3. So that value alone you take here. Okay, so and that value alone you can easily substitute. Okay, while substituting also you need to substitute correctly first generating unit and third generating unit. So that's why I said the problem itself, once you mark what is A1, B1, C1, A2, B2, like that B3, like that you mark. So after substitution, you can find out the lambda nu. What is the value of lambda nu? Lambda nu we are getting 8.714. 8.714. Next, what is the next step? PG1 nu. Calculating the PG1 nu. So what is the formula for PG1 nu? Same formula. PG1 nu is equal to lambda nu minus Bi divided by 2ai. So what is the formula for lambda nu? Lambda nu 8.714. So here you need to substitute 8.714 minus 5.2 the whole divided by 2 into 0.0045. So here if you take, so after substitution, so here you substitute correctly. Okay, what is B1 divided by what is A1, like that you substitute correctly, and here you need to take lambda nu. So the formula itself, PG1 nu is equal to lambda nu minus Bi divided by 2ai. So after this you need to take, because PG2 already satisfied, only you need to calculate PG1 and PG3. Okay, so PG1 you need to substitute all these values, that is lambda nu value and this coefficient value. So after calculating, so PG1 nu is equal to 390 megawatt. We are getting PG1 as 390 megawatt. See here again PG3 again because already we have calculated PG2. Again PG3 nu is equal to lambda nu minus B3 divided by 2a3. That you need to write, then you substitute. Don't substitute as I did. Okay, for simplification in writing in the board and writing in the notes, I have written simplification, but you have to write the formula substitution, then you go for the finding out the answer. Next, PG3 is equal to, so yeah, after calculating all this coefficient, that is coefficient of B3 divided by 2a3, so 5.8 divided by 2 into 0.007. So after this, we are getting PG3 value as 184.43 megawatt. 184.43 megawatt. After this, you finally you write the answer also. Don't stop here. Okay, don't stop simply like here. Finally, you take all PG1 is equal to 390 megawatt. Next, PG2 is equal to 350 megawatt. PG3 is equal to 184.43 megawatt. Comma, limits, minimum and maximum operating limits. What is given in the problem? Yeah, that limit also you should write. Okay, so then only the evaluator will know whether this answer is correct. Even though they know, but even if writing the answer will leads to get the full marks. Okay, full marks. So this limit after writing this PG1, PG2, PG3, this limits, that is 250 megawatt less than or equal to PG1 less than or equal to 450 megawatt. Like that, 200 megawatt less than or equal to PG2, PG2 less than 350 megawatt. So this three limits you need to write. So 125 megawatt less than or equal to PG3 less than or equal to 215 megawatt. So again, you need to verify the demand also, whether it is satisfying our demand also. If you verify, it will come not exactly 925 megawatt. Why? Because we rounded off like after decimal. So 924.99 or 924.85 or something. 924.9 is very good. If you get 924, so you can write like approximately equal to 925 megawatt. That is 924. So 924.9 megawatt approximately equal to 925 megawatt you can write. So tolerance limit already I said plus or minus 5%. Then if it is going, say for example 924 megawatt, also wrong one. If you are getting the answer as 924 megawatt, wrong one. That value 1 megawatt deficit will not come. So 1 into 10 to the power of 6, that is wrong only. 0.9 is good. 0.8 is also good. So don't come that's what after decimal 4 digits. If you defaultly, okay, by closing your eyes after decimal 4 digits only you need to take. So if you take like that, exactly you will get the exact answer. So you can the demand also satisfy. And the next finally conclude. So generating unit 1, PG1, PG2, PG3, generating unit 1, 2 and 3 satisfies the demand, and also it satisfies the minimum and maximum operating limits. Like that, you conclude. So if you conclude like this, you can get full marks. Okay, if you stop up to this, some without conclusion, any conclusion, you'll be losing your marks, 1 or 2 marks you'll be losing. And units, whenever you're writing nearby, you write the units. Okay, don't think like we can write it later like that, because we are dealing with megawatt. As I said, like instead of 390 lakhs, if you give, okay, you borrowed from bank like 390 lakhs, you are giving only 390 rupees. Whether the bank will accept? No. So that is the same scenario here. If you don't write the units, even then the whole problem is wrong only. Why? Because we are dealing with megawatt. What is the mistake here? That is a very, very blunder mistake. Instead of 390 megawatt, that is 390 into 10 to the power of 6 watt, you are calculating only 390 watts. That is wrong only. The whole problem is wrong only. 1 or 2 marks for step marks only you will be getting. So the unit is very, very important. So after concluding, we should stop the